Why is this important? Because improper draft and venting will cause you to have blowback, will cause you to have the smoke not leaving the house. It can kill people.
Shitty flame.
Bad flame.
A bad flame,
Yeah. Improper flame.
Was it the children?
So bad flame. You can have not because you're not drawing air very well. It can vary with temperature, how high the chamber is and the chimneys. And if you talk to Bill, he will tell you a lot of stories about that. We have chimneys. Chimneys are great because they are natural. They are designed to pull air by buoyancy. What is that called, Joe? Tell us. What is that called when the air goes by itself outside?
Chimney. Natural.
What kind of convection?
Natural.
Natural convection. Gravity is cheap. Gravity is reliable. It's free. Using its gravity to pull things out by itself. No need for induced draft whatsoever. So they used to build chimneys very well, that any heat will come out of the house naturally. But you don't find that anymore. People are gonna use those cheap vent, which is, it does the job. But again, we have to size them correctly, otherwise they're not going to vent properly. And again, if we don't have complete combustion, we will have CO and CO2 and all this kind of bad stuff. And if these stuff accumulate in your house, what will happen?
You could die.
You could die. And also, if you get a lot of headaches in your house, and the headaches goes away after you leave the house in 2 hours, it's not your family. It's something in there. Could be the air needs to be circulating. You're not changing the air too much. You get a lot of headaches. So that's one of the. If somebody in your family complain of a lot of headaches, maybe you should think about that. People do not think about.
Radon too.
Radon is a different story. I don't know if it causes cancer. But anyways, you gotta be careful with those gases. I think the law now in Massachusetts that you need to have a carbon monoxide in your house. However, everybody install them and they don't maintain them. Sometimes they're not sensitive. So be careful with that. And you're gonna be the eye who goes and be able to see these things. You know how when now you'll be able to notice these things. Before you didn't even look at them, right? But if you buy a camera, you're gonna see all the cameras on the street, right? Same psychology. You don't notice any camera until you buy one. All the Jeeps until you buy one or looking to buy one. It comes to your attention. So the same thing now when you go into a house, you're gonna see those pipes. The first thing you look in a house, you visit somebody, it becomes kind of crazy, but it's okay. You're gonna go, oh, I wanna see the boiler. What do you have for heat? What's happening? So you start to notice these things. So it's going to be upon you to go and check those things and make sure they're functioning properly. And it will be a lot of fun to go and see things that are not done correctly. And please send me pictures of those funky wires you see in there. They call them the bird nest. Like a whole bundle of wires stuffed in a box with some wire nuts, and we're done with it.
Hey,
Don't
the
touch
box is in the lab.
Yeah, don't touch that. Now, this is actually very neat compared to what you will see. You will see some pictures.
Oh, here we go.
So draft and venting. Every pound of air requires 14.5 pounds of air. So totally we have 15.5 pounds of product. So 1 pound of fuel will burn with 14.5 pounds of air, and you'll get 15.5 product that you need to remove out of the house efficiently and quickly. Draft is the suction of air into the chimney. So the last quiz that was confusing. No, it wasn't confusing. We had this air band here that pulls in forced combustion air, but we also have some natural draft coming in the chamber. As we burn the fuel, it will pull in some naturally. So that's why we always have something called a swing door in the chimney to make up for that vacuum. Question?
How do you weigh air?
It's theoretical.
So how do you know you have the right amount of air?
Well, some chemists did that equation for you, and you weigh the air. In theory, you can get the volume of the air. That's easy to know how much volume you put it there. Then you can get the molecular weight for the composition of that air, and you can estimate how much the weight of the air is. Same thing in how they estimate the weight for the gas. How are they charging you for gas? That's a big debate, by the way. What are you charging me for? can I verify that? And actually a lot of companies go in trouble for how much are they charging you for. Is it a third, is it a gallon, how much is the gallon? How much heat do I get out of the gallon? So you don't know, you're just gonna pay it. With oil, you know you're getting liquid. But again, can you verify the composition of that liquid? You really can't, but there are laws to keep these standards. And actually there are commissioners who goes to every gas station and measure take sample and do measurement to verify, because there's a lot of cheating going on.
Yes, it is.
Yeah.
You can tell when you fill your car, if it's a 15-gallon thing and you put in 18-gallon.
Or contaminated trucks or whatever. So we have natural draft that comes in, that's natural convection, torrential draft, which is basically different pressure. So if we have current, the current creates what? Pressure. And that pressure will pull in air with it. And I did that little experiment with the piece of paper. Let me do it again. Let's go torrential draft. So that's the torrential draft. If I blow straight air, it will pull in the, let me see if my lungs function. See, that's torrential draft. The air going up and it's pulling pressure and the air out. That's torrential draft. So you can always pull things in with you. When you see a rocket coming up, a lot of dust comes in, that's torrential draft. Forced draft, when you have an inducer fan, he just gave up on the design, he don't care anymore, he's gonna put a fan in there. Fan will cost you a lot of money to install, a lot of money to operate, and noise, and a lot of other things. Whenever in doubt, whenever you have a good design, you don't need a lot of forced draft, you can just use natural draft. And direct venting, that's when you have things to the outside directly. Okay, so draft development. That's what you will see a lot in the shop and in a lot of houses if you don't have a chimney. So this is how it works. You have fuel coming with air, burning in here. It's going to be hot, goes through your vent pipe, and you're always going to have a venting here, a swinging door.
Always?
You have to have it. It's the code.
What if it's a forced air system where it's?
You also need the balance, a damper. Why is that? If you don't have a damper, if you have a very high velocity here, what will happen? You will pull more air from the chamber, which you don't want. You want the chamber to be undisturbed. So whatever torrential draft you have in here, you want the supplemental air to come from here, not from here. Otherwise, you're going to pull more air, you're going to disturb the flow of air and fuel, and you're going to have flame all over the place. So you want to have a swinging door here. I will show you what it looks like. Yeah. So this is called a swinging door. Naturally, it is shut. And whenever there is some torrential draft, it will open up a little bit to give some air. If this is not opening, what's going to happen? You're going to force vacuum air from the chamber, and that is not good at all. So you need that in your.
How to tune up the thing?
Huh?
How to tune up this thing?
It should be, first of all, it should be freely opening, and when it's when the boiler is shut, it should be closed. When you open up, it should be opening by itself. And you see this weight?
Yeah.
It's the contour weight for it.
Basket.
Yeah.
Where
It should be
is the
easily
weight?
open, so swinging, like free opening. Yeah.
So if there's too much air coming through, does that affect how hot the heat exchange gets?
No, it's not about the heat, it's like the combustion. Again, we go back to
Combustion.
complete combustion. You have too much air now, so the flame gonna be all over the place. In complete combustion, we don't want that.
Well, that's gonna be the smoke and carbon dioxide.
Eventually, yeah, eventually, and other stuff. So draft, work and pressure difference, hot and cold air in a house, and infiltration, we talked about that a lot. I bored you with infiltration a lot. So pressure difference, and wind does affect your venting. If you're venting through a chimney and you have a lot of wind through the house, you might expect to have some kind of backdraft, or more draft coming out. And that's also why you need the swing door, so whatever pressure going through the chimney as a negative pressure, it will pull from the house and not from the chamber. And what happens if you have too much air? Let's think about the candle. When you blow it, the candle goes away, right? So it's possible if you have very strong draft coming through the chamber, those little flames in the gas barrier might go out. Well, then it will go in safety and come back again, hopefully. But you don't want that. Weight does have an issue. New versus old construction. Again, please go and check your basement and think about where is the boiler is getting air from. Look at it. If there's no opening, where is it coming from? A lot of basement doors have vents on them, so it will pull air from your kitchen or wherever the door go into the basement. Otherwise, you're gonna leave an opening. Well, there's no air. People don't think about that. People even build walls around the burner. So it needs some air to breathe. Otherwise, what is the easy way to do it? To ensure that there's air? What? You can install a whole harness around it and pipe it to the outside. Give it its own air from the outside and get it done with. If you do that, you have to again to recalibrate it because the air coming from the outside is kind of cold, and the inside, so it has to be calibrated again. Especially with the old ones. So again, remember in cars back in the days with the carburetor. So if you drive the car in New England, you have to change the carburetor setting. If you go to New Hampshire in the mountains, it's not gonna perform very well. It starts shaking, and you have to go and adjust. If you go to a hot place like Texas, it will wanna be different. So with the carburetor, you have to always do an adjustment. The new ones, the new cars, they have an automatic damper, and the engine will just measure the air using oxygen sensors. Who's doing oxygen sensors? You're doing oxygen, okay. So we measure the oxygen coming from the incoming air, the oxygen coming from the outside of the engine, and okay, you say we need more air, they'll open the damper a little bit more. It's control is very amazing because it will ensure that you have good combustion, and it is less work. I mean, back in the days when you drive a car, you have to warm up the car, you have to check this and that and the other. You have a schedule that you have to follow all the time. It's becoming less human interaction now. You just hit the ignition and drive. So here we have cold air. Cold days that's heavy. If the chimney is too long, people don't want to do the calculation to vent into the chimney. They will vent into your into a regular vent. That will blow down the air into the chamber, into the boiler. So weight doesn't make a difference. And again, a lot of people do not vent through chimneys because they're afraid not to do the right calculation, and the cold air will come and push through the flame. However, if you go through the chimney length and formula here in the book, you'll be able to estimate if this is okay or not, or should I just like do the shortcut and get my own vent to the outside and get it done with. So that's something you could do. Okay, I'll stop here and I'll finish the stuff. Hopefully this chapter on Tuesday.